Hello and welcome, this is SLO 9. The goal of this video is to be able to solve application problems involving periodic data. Here are some basic definitions for some terms. The amplitude is the distance from the midline to the minimum or maximum. A period is the length of one cycle in a graph, and it's found by using 2 pi over b. The frequency is how many cycles that pass in a given unit. This is found by b over 2 pi. This means that period and frequency are inverses of one another. Let's cover some basics regarding periodic functions. So a typical periodic function is written in this form: y equals av sine x minus c plus d, or y equals a times b cosine x minus c plus d. The only difference between these two is that, sine of x and the cosine of x here. A period, again, is found by doing 2 pi over b. The amplitude is the maximum minus the minimum divided by 2. And this is always an absolute value, so it can't be a negative. The horizontal shift is represented by c, so c indicates how much it moves left or right. And b is really just 2 pi divided by the period. Just manipulate 2 pi over b to get b. And the vertical shift is d, which is the maximum plus the minimum divided by 2. If you write y equals whatever the value of d is, you also get the midline. So this is just a quick refresher on what a general sine and cosine graph looks like. Sine is this orange line over here. It starts at its midline and moves to a maximum. This is for y equals sine x. And for y equals cosine x, we actually start at the maximum and go down to a minimum. If you think about this, this connects to the unit circle, so consider that the sine of 0 is 0, but the cosine of 0 is 1. And then all of these values like pi over 2 and pi and 3 pi over 2 correspond to the graph and the unit circle. They're connected. The main difference between sine and cosine is this phase shift here. So sine is to the right pi over 2 units compared to cosine. Here is what the unit circle looks like again. Again, you'll see these values reflected in the graph as well. Let's quickly look at some examples. A clock has a 15-foot radius on top of an elevated base that is 12 feet off the ground. It takes 60 minutes for the minute hand to rotate around the clock. The minute hand is bolted down at the center with the tip to the end of the clock. How long is the tip of the minute hand above 34 feet from the ground? Assume the clock starts positioned at 12 o'clock. So knowing the clock has a radius of 15 feet means the amplitude is 15 feet, because that's how much the tip of the minute hand can go up or down by. The period is 60 minutes because it takes 60 minutes to go around the clock to fulfill one cycle. And we know the period, so we can set the period to equal 2 pi over b to find the value of b. So we have 60 equals 2 pi over b, and if we manipulate this, we could have b equals pi over 30, because in this equation, we could multiply both sides by b, and then divide by 60, so 2 pi over 60 simplifies to pi over 30. The vertical shift is found by finding the maximum and the minimum, adding them together and dividing by 2. So knowing that the lowest point the tip of the minute hand can go is 12 feet because it's 12 feet off the ground, and that the highest it can go is 42 feet, because if you add 12 plus 15, you get 27, plus another 15 is 42 to get the highest point. So we have 42 plus 12 divided by 2, and we get d equals 27. This allows us to write an equation. We'll have 15 cosine pi t divided by 30. Because of our p-value, we don't have a phase shift of any kind, so we don't have to worry about that, plus 27. So the reason we know this is a cosine graph is because when the clock starts at a 12 o'clock position, we know that the minute hand is at the highest point it can be. And since cosine graphs start at a maximum, we know we're using cosine. But let's look at it graphically. So again, we have this here. We know the lowest the tip of the minute hand can go is at 12, and we know the highest is 42. So we can graph some points. Here we have at 0, at 12 o'clock, or the 0 minutes have passed. The tip of the minute hand will be 42 feet off the ground, and we know when 60 minutes have passed, the minute hand will be in the same spot at 42 feet off the ground. The midpoint would be at 30, and this will be at its lowest point. So over here, and it'd be at 12, and then between these 2 points, it would be at 27 feet off the ground, because that's the midline, and again, it's between the maximum and the minimum, because we have to think about it as it would be right here or here. The tip of the minute hand would be here or here, meaning it's 12 plus 15 feet off the ground, which is 27, and this happens at 15 or 45. So let's connect these points to draw a graph. So here is the general curve. If we kind of hand draw it here, again, y is the height, x is the amount of minutes that passed. So knowing this, we now have to set the equation equal to 34 to find out how long this equation represents the tip of the minute hand being above 34 feet. So if we set up our equation, we again have y equals 15 cosine pi t over 30 plus 27. We're going to set this equal to 34. So subtract 27 for both sides. You have 7 equals 15 cosine pi t over 30. Divide both sides by 15. You have 7 over 15 equals cosine pi t 30. Then to get rid of the cosine, to isolate t, because again, we're solving for time, we'll have to take the inverse cosine of both sides. So inverse cosine of 7 over 15, these cancel out. We have pi t 30. Then we're going to multiply each side by the inverse, 30 over pi and 30 over pi. So 30 over pi times cosine, inverse cosine, 7 over 15 equals t, and that's about 10.36 minutes. Now, if we look back at the graph, this point here, when it's at around 27, that's at 15 minutes, but at 34, we could say that's around 10 or so. So knowing this, we only have one side represented from the equation, but there's also this part here where it's above 34 feet and above. So coming back here, we actually have to multiply this by 2. So do 10.36 times 2, and you'll get that the minute hand is above 34 feet for about 20.72 minutes, and this is shown on the graph. We have one more example for this, but this will come in part 2. So this is the end of part 1 of SLO 9. Stick around for part 2 in a bit.